Okay, so we're going to talk about the even odd identities and also the cofunction identities on your gold sheet. So I'm going to do like a little mini notes explanation here right by number 1. And I'm going to label this my my even odd. That's what we're talking about. Even and odd identities. So this is numbers 12 through 17. Okay, so in order to explain this, I'm going to draw a little coordinate plane action here. Oh, let's try that again. Okay. And who remembers the acronym for which trig functions are positive in which quadrant?
All students take calculus.
All students take calculus, that's right. So A, S, T, C. Okay, I'm going to color code here. So I'm going to use blue as my cosine values, and I'm going to do green for my sine values. Okay, just to remind you guys about the coordinate values for cosine and sine. So cosine is going to be positive in the first quadrant and in the fourth quadrant, right? And it's negative in the second quadrant, and it's negative in the third quadrant. And these are all just based on our ordered pairs. So then if I look at sine, sine is my y value. So sine is positive in what two quadrants? The first and second, right? Which means that it's negative in the third and the fourth. Okay? Hopefully that looks familiar because we've talked about that already. Okay, so then if I look at my even and odd identities, let's look at like the, let's look at cosine and sine. So we'll look at number 12 and number 13. And I'm going to pick an angle measure. Let's just pick pi over 6. So this value right here, that's my pi over 6 angle. Okay, and if you don't remember what that coordinate point is at pi over 6, that is on the back side of your unit circle. Okay. Your coordinate pair is square root of 3 over 2, comma 1/2. So what this identity number 12 is saying, it says that the sine of our negative angle is equal to the negative sine of that angle. That's what that identity number 12 says. Okay, so if I look at that in terms of an example, like sine of negative pi over 6, that means instead of it being in the first quadrant, when I draw my angle, it's actually going to be in the fourth quadrant right here, right? So this is negative pi over 6. So the y value of negative pi over 6, well, that's just negative 1/2, right? You guys agree with that? Which means if I just looked at instead negative sine of pi over 6, well, pi over 6, my y value is 1/2, so that's equal to negative 1/2. So they're the same thing. Whether there's that negative on the inside for my angle, it's going to give me a negative sine value of whatever function or whatever angle I choose. Okay, so that's like example 12. 15, which is the reciprocal cosecant, same thing. It's gonna give you the negative. And same thing for 14 and 17. So tangent and cotangent, if you look at your gold sheet, they both inside have a negative, and then on the outside when they rewrite it, also have a negative. Okay? 13 and 16, cosine and secant, however, become positive. Okay, so how and why is that? Let's look at an example and find out. So let's look at example number 13. So that's looking at cosine. So cosine of negative theta, they say, is equal to cosine of theta. Okay, let's start out with the positive one. What is cosine of pi over 6? Let's do cosine of pi over 6. what is my x value of cosine of pi over 6? Root 3 over 2. So this is equal to root 3 over 2. Now if I plugged in my angle here, negative pi over 6, well, that now becomes my blue line right here, right? So cosine of negative pi over 6, what's my x value down here still? Root 3 over 2. It didn't change, right? Because it's still positive in that fourth quadrant there. So your even and odd identities here, if they're inside and they're negative, it's going to produce a negative trig function unless it's cosine and sine, or sorry, cosine and secant, they're going to produce a positive version, okay? But basically all you need to be able to do is take this thing right here and plug in your negative sine of theta, basically use all your puzzle pieces in order to simplify or verify your trig identities, okay? Does that make sense? All right, let's look at it in an example. So number 1 here, we've got sine squared of negative x. So if I look at sine of negative x, what does that give me? Negative sine x, right? But it is still going to be squared, okay? So that's using your property number 12 from your gold sheet. And that is all divided by tangent squared of x. Okay, so I can go ahead, let's go ahead and rewrite tangent in terms of sine and cosine, so that way I can simplify this a little bit further. So I've got negative sine squared of x, and then I think it might help a lot of you guys if you wrote it like this, dividing by, and then tangent squared of x is technically sine squared over cosine squared, right? We okay with how I rewrote that? Okay. And now if I'm dividing by a fraction, that's the same thing as doing what? Multiply by the reciprocal, so I got negative sine squared x times cosine squared over sine squared, which happens so very nicely to do what for us? Cancel out those negative or sine squared of x, which leaves me with a negative cosine squared of x. We got it down to one term. It's not a fraction. There's nothing else that I can do. Okay. Any questions? Okie doke. So the next one that I want to talk about before we talk about cofunctions, let's go down to number 6 and try out number 6. So we're verifying, so we're choosing the more difficult looking side, and then we're simplifying that to make it equal to the other side. So obviously more difficult side here is the fraction, not 1, right? We can't really do anything, I mean we could, but it's not gonna work. So I'm gonna simplify this left-hand side here and make it equal to 1. One thing I want you to remember is back in algebra, if I had something like x squared minus 9, how would I factor that? X plus 3, x minus 3. Right? So anytime you see a difference of two squares, two perfect squares, we can rewrite it in terms of our two factors. Do you guys see that? Our perfect squares, sine to the 4x and cosine to the 4x. So I could rewrite this numerator as sine squared x plus cosine squared of x, and then times sine squared x minus cosine squared of x. And if I would FOIL that back out, I would end up getting my numerator. Okay, now what could I do?
The denominator cancels out with one of the first.
You got it, the algebra. Those go away, those go away. So now I've just got sine squared of x plus cosine squared of x. And what does that equal? That does equal 1. Back from our identity number 9. So we did in fact get 1 is equal to 1. Okay, so using that difference of squares allows us to solve this a lot easier, and truly I'm not sure if I would have been able to do it a different way. So yeah, any questions on that one? Okay, so in this one right here, we see this cosine of pi over 2 minus theta thing, okay? We briefly talked about this either last 2 units ago, I think, maybe 3 units ago, but these are what we call our cofunction identities, okay? These cofunction identities are basically these 2 different things that add up to give me 90 degrees, okay? If we think about it, like look at this one right here, cosine of pi over 2 minus theta. If I have a cosine of an angle, let me draw a little picture here. Okay, let's say this is pi over 6, and then our coordinate point is square root of 3 over 2, 1/2. Okay, what this formula is saying is that this is equal to sine of theta. Okay, so if I let my theta equal pi over 6, well, what is sine of pi over 6? Sine of pi over 6 is 1/2, right? If I plug it into my formula, cosine of pi over 2 minus pi over 6, if I simplify that, pi over 2 minus pi over 6, what does that give me? That'd be like 3 pi over 6 minus pi over 6. So that'd be 2 pi over 6, which is pi over 3. We good with that fraction work there? Okay. And so cosine of pi over 3, or pi over 3, is up here. Oops. And if you don't remember your coordinate points for that, it's 1/2 comma square root of 3 over 2. So cosine of pi over 3, my x value of pi over 3 is also 1/2. Okay. It's because sine and cosine, these 2 things are complements of each other, right? That's where this formula comes from. The complement of cosine is sine of that angle minus pi over 2, okay? Does that kind of make sense how that formula works there? Okay, so your sine and your cosines, those are cofunctions of each other. And then your cotangent and tangent are cofunctions of each other. But basically, all you got to be able to do is, look at these formulas here and plug in. Anytime you see like a pi over 2 minus an angle, you're going to replace that with the trig function, okay? So, let's go ahead and rewrite the numerator there then. So, secant of theta, sine of theta, plus sine of theta, all divided by 1 plus cosine theta. Okay. Now, almost everything's in terms of sine and cosine except for secant. So let's rewrite secant in terms of sine and cosine. What's secant equal to? 1 over cosine. So I've got 1 over cosine times sine plus sine of theta, all divided by 1 plus cosine of theta. Okay, if there's an addition sign, that means we probably should do that addition. So if I want to add these 2 things together in the numerator, what's my common denominator going to be? Cosine. So I'm going to multiply by cosine and then divide by cosine. And when I do that, I end up getting sine over cosine for my first fraction. Oops. But then I'm just going to extend this here because then I've got plus sine theta cosine theta. So that's my numerator. And then I'm going to rewrite it like this. I'm dividing by 1 plus cosine of theta. So dividing by 1 plus cosine is the same thing as multiplying by what? One over 1 plus cosine, right? So I'm going to rewrite this whole thing up top, sine theta plus sine theta cosine theta over cosine theta. And that's times 1 over 1 plus cosine theta. Pause for a second. Make sure that you guys see where all of that stuff came from. Now, what could we do? This 1 plus cosine. I've got a cosine up here. Could I make it into a 1 plus cosine somehow? Could I do something here? Could we take out a sine from both of those? If I factor out a sine, I'm going to be left with 1 plus what? Cosine, right? Because if I divide both of those by sine, that's what I get. And then I've got still divided by cosine and times 1 over 1 plus cosine. So now what happens? So then from here, I've got a 1 plus cosine, 1 plus cosine. So I can go ahead and get rid of those. Yeah, 1 would go away technically, right? And then I've got left over with sine theta over cosine theta, which is tangent. It was a little crazy, but also maybe a little fun. Tiny bit? Maybe?
That's a little bit fun.
A little bit? Okay. Okay, any questions on how I got to that final answer? Okay. Okay, I want you guys to try starting out number 10. You're going to use your cofunction identity and see what you can do, okay? Give you a minute or two and try some stuff out. So first thing, my cofunction. What is this cotangent of pi over 2 minus x? Tangent. So I've got tangent of x times secant of x, all divided by 1 minus secant squared of x. Now, some of you switch this into sine and cosines right away on the numerator, which is fine. However, what is this denominator going to equal? 1 minus secant squared. 1 minus secant squared is what? Tangent, right? So I've got tangent x times secant x over tangent square root of x, right? So I can get rid of one of my tangents, but I still have secant over tangent and now, again, there's more than one way that you could have done this, but now I would go ahead and change this into my, well, we could do one of two things actually. I just thought of another way that we could do this. Because tangent, if you look at your number 7, tangent is secant over cosecant. I'm going to try it that way. This probably isn't how you guys did it. That's okay though. Secant x divided by tangent, so divided by secant x over cosecant x, which would be the same thing as times the reciprocal. So I could cancel those out. Oh wait, I missed a negative somewhere. Where's my negative?
Tangent's supposed to be negative.
Ah, yes, tangent's supposed to be negative down here. Thank you. Thank you, thank you. All right. Then I ended up with my answer of negative cosecant of x, which is what I was supposed to get. Now again, you might have done it a different way. Anyone changed it like into your sines and cosines here? Yeah? Did you get the same thing though? Yeah. So either way is fine as long as mathematically it makes sense and you get to your final answer of your verifying. Does that make sense? Cool. Great job. Okay, the rest of class, we're going to take a quick break. And then the rest of class is going to be work time on the review. The answer keys posted. Again, next class will be your quiz after we have about 20 minutes of review to go over questions and things. Okay? Sound good? All right.